Hey, all you cool cats and kittens. We are starting chapter 9. So, going into graphing and relationships and linear relationships, which we have gone over last year in grade 7 as well. We're just going to sort of be continuing that stuff. So, I'm going to do this. This is a bit of an odd chapter for me being able to see your work and for doing the work together. It's definitely a lot easier when we are live and together, but we're going to do our best. The easiest way that I can explain this unit is just to go through some examples with you. So I'm going to go through some examples from the textbook, and then you'll be doing some other questions from there. Okay, so we're looking at these graphs and these relationships. So the graph shows, so this graph below shows the increase in total height for each step of a staircase. So as you go up a staircase, it gets higher, which makes sense. So on the x-axis, so remember the horizontal is the x-axis, the vertical is the y-axis. So on the x-axis, we have the number of steps, 1, 2, 3, 4, 5, 6, and so on. And on the y-axis, we have the total height that you've gone up, 20, 40, 60, 80, 100. So if you've gone up one step, you've gone 20 centimeters. If you've gone up 2 steps, you are at a total height of 40 centimeters. If you've gone up 3 steps, you've gone up a total height of 60 centimeters. 4 steps, a total height of 80 centimeters. Okay, so this is the information that this graph is showing us. So you can describe the patterns that you see on the graph. There's lots of ways to do this. There's going to be questions about this a lot, describing those patterns. You can describe it a lot of ways. One way is you can say it's a linear relationship. The graph makes a straight line. So all these lines, you can connect them, and they make a straight line going through the graph. So this is a linear relationship, which means that they're going up consistently. You could also say something like, oh, for every one step you go up 20 centimeters, because we see with one step you went up 20, then another step you went up 20. You can also talk about horizontal and vertical movements. So for every 1 unit we move to the right, we move 20 units up, because this doesn't go up by ones, this is going up by 20 each time. Okay, so there's actually like 20 in between here. So lots of ways to describe it. It's sort of always a weird question when they're asking you to describe the pattern. But that's what it's sort of looking for, is just, you know, how many horizontal and vertical units are you moving each time? You could also just say, you know, essentially describe what it's showing you. So what we did at the start was just saying, okay, yeah, you go up 20 centimeters for every step that you take. That's as much as you need to describe it. Okay, let's make a table of values from the graph. So for B, we're making a table of values. So this is remembering back to last year. We could make a table of values, because the table of values really shows unit pairs. So X and Y together. So we always have X on the left side. We could also draw our table of values going horizontally, in which case we'd have X at the top. And then Y is next. So Y is either on the right or the bottom. So X, which is horizontal, is on the bottom. This is the number of steps. So X is the number of steps. And Y was the height. Okay, you could do this horizontally as well. It doesn't really matter. I'm just going to do it vertically. You only need to do one or the other. So we have only certain numbers that go together. So when you've gone up 0 steps, what is the height that you've gone? Well, they actually don't have a point there. But at 0 steps, you would have gone 0 centimeters. When you've gone 1 step, so when we've gone 1 step, the graph tells us we've gone 20 centimeters. When we've gone 2 steps, the graph tells us we've gone 40 centimeters. 2 is 40, 3 is 60, and now we see this pattern. 4 is 80. Okay, and this pattern would continue. And so, if the pattern continues, what is the total height on step 10? What would the total height be? So we can solve this a couple of ways. One way is to say, well, just to continue it and just say, okay, 5, 100, 6, just erase 10, 120, 7, 140, 8, 160, and so on, and we could do 9 and 10. Another way is to look and think, well, what am I doing here to get my x to equal my y? Okay, and so if x is going up by 1 each time, and y is going up by 20, that means for every x, for every step, we're going up by 20 centimeters. So whatever number of steps I'm going to, I could just multiply that by 20. So we see here, if we've gone 1 step, 1 times 20 is 20. 2 steps, 2 times 20 is 40. 3 steps, 3 times 20 is 60. So every time, we're able to multiply the number of steps by 20 to get our total height. So if we're at 10 steps, we can times it by 20 to get 200 centimeters high, 2 meters high. And if we continued this pattern, going up by 20 each time, going up by 20 each time, going up by 1 here each time, when we get to 10, we'll have gone 200 centimeters. Okay, so we have this relationship, this linear relationship. A linear relationship is any relationship that is consistently going up by the same amount. So x is going up by a consistent amount. In this case, it's going up by 1 every time, and y is going up by a consistent amount. In this case, 20. So when you graph it, it makes a straight line. Okay? Just a quick thing. Tell whether you think it is reasonable to have points between the ones on each graph. So we have our graphs, and often they just show these certain points, right, as it goes up. Does that mean that that's the only data that can fit on this graph? Well, it depends. And it depends what we're looking at. So here we have cost and distance. So you have, if we look at graph A here, it costs $2 to go 0 kilometers. It costs to go 1 kilometer, it costs $3 is in between 2 and 4. To go 2 kilometers, it costs $4. To go 3 kilometers, it costs $5. But would it make sense to have points in between? Could you go 1.5 kilometers and pay for that? Well, yeah, you can go 1.5 kilometers. And you could potentially have a cost that is then in between 1 and 2 kilometers. So distance, in this case, is something that you could have points for in between. You could go 1.75 kilometers. You could go 3.9 kilometers, so not quite 4, but 3.9, and so your cost would just be a little bit less in line with that. Okay, so in graph A, you definitely could have points in between. And then so sometimes when you can have points in between, you can actually connect those lines. When we look at graph B, we're looking at cost. So again, we're looking at dollars, but now we're comparing the cost to the number of cartons of ice cream that you're buying. So if you buy 1 carton of ice cream, it's $4. If you buy 2 cartons of ice cream, it's $8. 3 cartons of ice cream is $12. So every carton of ice cream is $4. So it doesn't make sense that you could have some points in between here. Well, can you go to the store and are you allowed to buy 1.5 cartons of ice cream? No, you cannot buy 1.5 cartons of ice cream. They don't let you cut 1 in half and just pay for half of it. If you did that, you'd have to still pay for the whole thing. So it doesn't make sense in graph B, it doesn't make sense to have points in between. Okay, so depending on your situation, sometimes you can have data that lies in between the graph points, and other times it doesn't make any sense at all. Okay, so you just have to sort of look at it and just think, Does it really make sense? And then decide. Okay, let's do this question. Oh, this is too big for this page. There we go. Okay, the graph shows the cost of dried apricots at Bulk and Save. I love dried apricots. So, well, my mic was moving around like crazy. The cost of apricots, this graph shows the cost of apricots in total. So you're paying for a quantity in grams, and then we have the cost on the side in cents. It's sort of hard to see, but that's in cents. So first, let's make a table of values from the graph. So again, the x value, the quantity, always goes on the left. So the x value is always on the left, the y value is always on the right. Or let's do it horizontal this time, actually. So the x value goes on the top, the y value goes on the bottom. The x value on the horizontal is quantity. Quantity in grams. And the y value is cost in cents. Okay, now we look at our points. So we look at this first point. Well, the x value is 100. So for 100 grams, you are paying 75 cents. Then for 200 grams, the next point, you're paying 150 cents. And then for 300 grams, you're paying 225. So 300 grams, paying 225. And then for 400 grams, you're paying 300 cents. So 400 grams, 300 cents. Okay, and here's our table of values. So describe the patterns on the graph. So what is this graph telling us? Well, for every 100 grams that we go up, so every time we go up by 100 grams, every 100 gram increase, how much is our cost going up? 75 to 150 is 75 cents. 150 to 225, well, 150 to 200 is 50, and then 200 to 225 is another 25, so that's another 75 cents. 225 to 300 is another 75 cents. So this, the patterns on this graph is telling us that you're paying 75 cents for every 100 grams. Okay? So use the graph to estimate the cost of 350 grams of dried apricots. So 350 grams on our graph would lie about here. Does it make sense that we could have units in between? Definitely it does. If you go to any bulk barn place, you just fill up a bag, and then you go pay for however much is in there. That could be, 232 grams. It could be 568. So there's definitely grams, there's definitely values that could lie in between these points. And so we could pay 350 for 350 grams would be right in the middle here, which would end up being right in the middle of the cost of 300 and 400 grams. So we'd be looking at between 300 and 400 grams is 350. So we'd be looking between 225 and 300. So what about is between, well, between we could make an estimate 300 and 220. That's 80 is difference there. 80 divided by 2. It's 40, so I could add 40. So maybe like 265 or something. So you could make an estimate. 265, I said. That could be one estimate. Some of you would maybe make just a closer estimate. You could actually just calculate. And to calculate, you'd find what is the actual cost of 350 grams of dried apricots. Okay, so we know it's going to be half of 75 cents, since it's going up by 75 cents every 100 grams. To go up by 50 grams, it's going to go up half of 75 cents. So 75 divided by 2 is 37.5. So you'll be going up 37.5 from 225 cents to get to our answer. So 37.5 plus 225 brings us to 262.5. 262.5, I guess we're talking about cents. Okay, so compare your answers in part C and D. Well, mine were quite close, right? I just made a bit of an estimate before, but my estimates and were only off by 2.5 cents. So they were very close. So using graphs can be very useful for making those estimates and can help you get very close estimates. I just want to quickly talk about another way that we can solve this. So we paid 75 cents per 100 grams. So remember this unit when we were solving these ratios and rates using proportional reasoning. So if I paid 75 cents per 100 grams, another way we could have solved D, finding the actual cost, is to say, well, if you had 350 grams, how much would you be paying? Well, to get from 100 grams to 350 grams, we multiply by 3.5. And then I could multiply 75 by 3.5 to get the same thing. 75 times by 3.5 equals 262.5. So that was our answer. Okay, so that's one way of doing it. You could also say, well, if it's 75 cents per 100 grams, that's equal to, well, how much is that equal to for 1 gram? Well, 75 divided by 100 is going to be 0.75 cents per 1 gram. And then if I want to get to 350 grams, I times that by 350. So I'll have 350 grams instead of 1 gram. So 350 times by 0.75 is equal to 262.5. So the same thing. So we can use our proportional reasoning and our understanding of fractions and ratios and rates like this to be able to solve these problems as well. Okay, so another way to do it, you're just having to recall back to the math that you learned near the beginning of the year, actually. Okay, at Chow Restaurant, Mario works in the kitchen for $10 an hour. Susie works as a server. She gets $30 monthly clothing allowance, plus she gets $8 an hour. Okay, so let's just look through some of these questions. So which color of points provides information about Susie's wages? So which one of these lines matches Mario's and which matches Susie's? Okay, so for this blue, when they worked 1 hour, they got paid $10. When they worked 2 hours, they got paid $20. 3 hours, they got paid $30. So they're getting paid $10 for every hour. So that must be Mario, who's getting $10 an hour. So the blue is Mario, which must mean that the red is Susie. But let's just check what the red shows. So at 1 hour, the red dot is, well, it's about at 38. When it's at 2 hours, it's at, I don't know, so it's near between 40 and 50. Looks around 45. Now, if Susie gets $30, that would make sense, and then she works her first hour. She gets the $30 for clothing plus the $8 an hour, so she would be at $38 here. After 2 hours, she would be at 38 plus another $8. So this should be 46, and it's probably pretty close to 46. Okay, and then the line continues from there. So blue is Mario and red is Susie. Okay, so make a table of values with 3 columns showing time worked, H, and total pay for Susie and Mario. Okay, so time worked is on the bottom. So that's going to go first because that's our X value. So time in hours. We can compare that for both of them. So they both can work 1 hour, and then we have Mario's pay and we have Susie's pay. Okay, so when Mario works 1 hour, he gets $10. When Susie works 1 hour, she gets the $30 plus the $8 per hour. So she gets $8 plus that $30, so she's actually at $38 an hour. After 2 hours, Mario gets $20. Susie, she gets another $8, so we're at 46. After 3 hours, Mario gets $30, so he gets another $10 an hour. And Susie gets another $8 from there, which would bring her up to 54. Okay, at 4 hours, Mario gets $40. Susie gets 54 plus 8 is 62. 5 hours, it's 50. And 62 plus 8 is 70. And so now we're getting closer. We see the difference between their pay after 1 hour. Mario got 10, Susie got 38, so there's a difference of $28. Now after 5 hours, the difference in how much they've gotten paid is actually only $20 between 50 and 70. Okay, so this is up to the last point is 5 hours shown on the graph. So if the pattern continues, at what point will the two sets of points meet? Okay, and so this is going to continue, and to find this point, we could actually just keep going. So 6, 7, 8, 9, 10, 11. You could just keep the points going. So at 6 is 60, Mario 70, 80, 90, 100, 110. Then you get 112. Well, let's see if we can get there in this. Otherwise, we might have to extend it. So going up by 8 is 78. Going up by another 8 is 86. Sorry, slow math right there. And then 94. And then 94 plus another 8 is 102. Plus another 8 is 110. Hey, we're getting close. There's only a difference of 110 now. We can continue our pattern. Oh boy, let's just keep these. So 11, 12, 13, 14, 15. So at 15, Mario's getting 150. 120, 130, 140. Okay, this is one way to solve it. I will show you another way to solve it, but it's a little bit beyond the math that we're doing now. So 110, then 118, and then 126, and then 134, and then 142, and then look at 150. Okay, so after 15 hours of working, they will be getting paid the same amount. And then after that, what's 16? That's going to be $160 for Mario and only $158. Whoa, $158 for Susie. And that's going to continue. That Mario's is going to be increasing more than Susie's. And so after 15 hours worked in a month, Mario actually will be making more money. So even though Susie starts off making quite a bit more at the beginning of the month, realistically, since she's only getting that $30 once a month, they could easily be working more than 15 hours per month, and it would actually pay more to have Mario's job than to have Susie's job. Okay, another way we can sort of solve this, and this is maybe a little bit beyond what we're doing, but we can look at Mario's pay, which is 10 times by the time worked, and we can look at Susie's pay, which is 8 times by the time worked minus plus the $30. And we can say, when are these two equal to each other? So when is 10t 10 times the number of hours worked equal to, so that's Mario's pay, equal to Susie's pay, which was 8t plus 30. Okay, so if this is confusing to you, you can just ignore this equation because this is actually a little bit beyond what we're doing. But I can simplify this, and I can keep things balanced. I'm going to subtract the 8t, 8 times the hours from this side. I'm going to subtract the 8t from this side as well. So these cancel out. 10t minus 8t, well, if I have 10t and I'm minusing 8t, that leaves me with 2t is equal to, all that's left on this side is 30, so 2t equals 30. I divide by 2, and I divide by 2. Well, the time, what t would have to be equal to, the number of hours worked to make 10 times t equal to 8t plus 30 would be 30 divided by 2, which is 15. Okay, so when they're set to being equal to each other, we can solve for what that variable is equal to, since they're both working the same. They're both working for hours. And that, we notice, is the same as the answer here. They worked for 15 hours until they were paying the same amount. Okay, so a little bit of a more challenging question, this one. You can just continue your table of values to find when they meet using this algebra here. It's a little bit beyond what we're doing. That's more grade 9 math. But something probably lots of you could do. Okay, so here's the start of this unit. Sort of just an odd start to the unit. We're just looking at graphs and reading graphs and really just looking at being able to write a table of values from a graph and then just understand what this graph is telling us. Okay, so that's all that we're focusing on right now. There isn't going to be a Google form quiz this week just because it's too hard to get you to show your work that way. So I'll probably just get you all to submit just a picture of the work that you've done from the textbook, just so I can see that you've done some work. Okay, so as always, let me know if you have any questions, and I will be available on Thursday morning from 9 till 10:20 if you need help. Have a good day, grade 8.